Hello everyone, I'm Dr. Sri Banerjee, core faculty for the College of Health Sciences and Public Policy at Walden University with a joint faculty appointment at Rouse University School of Medicine. And I wanted to start off here talking about chlorofluorocarbons. I know we breezed over the material if you saw some of the previous podcasts or lectures. Anyway, I'm going to be talking about more detail about the chlorofluorocarbons and what type of effect it has in the atmosphere. One thing to keep note as I'm going to be giving you the instructions is that free chlorine, you don't want to have that because free chlorine can actually interact with about 100,000 oxygen molecules. Or ozone molecules. So literally chlorine can take 100,000 and break it apart. Another thing I wanted to say is that, and this is, think about like antifreeze, think about all the exhaust fumes from airplane, things like that. Once it's released, all it needs to do is interact with UV. And you have this dangerous free chlorine, which can then break down 100,000 ozone molecules. So here's B, ozone destructions, and when I say destruction, it doesn't mean a small destruction. As I said, it's heavy duty destruction. And then chlorine reservoir, which is unreactive, and so this is getting removed, and then so here's the stratosphere, here's the troposphere, and then so there's a line between the stratosphere and troposphere. And so once it's beyond into the stratosphere, this is all happening. But the CFC release is going on from below the troposphere. So it has to be removed, and once it's removed, it's better. Anyway, so we're going to go back to chlorofluorocarbons plus UV light, and then that's CFL2. And again, this destructive free chlorine, which we don't want. Oxygen plus Cl, so oxygen plus the free chlorine gas yields in chlorine oxide plus oxygen, and then chlorine oxide plus O leads to Cl plus O2. So chlorine can react with as many as 100,000 ozone molecules. So we already said that. And then in the C reaction, and so what it is, the way it's set up is that A, B, and C I'm describing here. So going from CFCs to free chlorine, this is what's happening. CFC plus UV light is going to CFCl2 and then free chlorine gas. So that's A, and that corresponds to A. B is ozone plus Cl, that yields in ClO plus O2. So that's how ozone destruction is happening. And then ClO plus O yields in chlorine gas plus oxygen. This is that free chlorine. So now let's look at C, what's going on. So free chlorine reactive is going into chlorine reservoir unreactive. So what's going on here? So ClO plus NO2 yields in chlorine nitrite. So again, keep chlorine from reacting with ozone, so it's occupied. And then chlorine plus methane, which yields in hydrochloric acid plus methane. So these are interference reactions, keep chlorine from reacting into ozone. So the blue is good, and then the A and B are not so good because of that free chlorine. So I know this is a little bit of chemistry, but I hope this has helped you to understand what is going on with chlorofluorocarbons. Thank you for listening.